We're going to talk about securing your GraphQL backend with JWTs. And this talk was inspired about sometime last year, I guess they're almost a full year now. Hasura came out with this article on the ultimate guide to handling JWTs on the front end, and it sparked a lot of conversation. It sparked a lot of discussion and questions, and it let me know that Auth and GraphQL is actually kind of a difficult topic for everybody, and I thought maybe it'd be useful to build a talk that was all about Auth and GraphQL from the back end. And it's true that Auth and GraphQL can be really confusing, I think, especially when you get to the back-end side of things. And I think part of that is because when we're building a REST API, we know that we're going to need to add some sort of middleware where we have a whole bunch of different endpoints, and so we can just kind of slap a Auth middleware on it and kind of call it good and move on. But then with GraphQL, of course, we just have this one big endpoint. And so it's a little bit less intuitive to know what we're supposed to do in order to secure our GraphQL endpoint. Do we just lock down the whole thing? Can we secure bits and pieces of it? And so that's what we're going to talk about in this talk. So Shruti already gave me a really nice introduction. I'm Sam Julien. I am a developer advocate at Auth0. We're an identity as a service platform. Basically, we handle the login and user profile and everything for your app. Try to make it easy for you so you don't have to worry about it. I'm also a Google developer expert, and I teach in a few different places. I make courses for Thinkster and also on Egghead. So in this talk, all of the examples and code and everything is going to be in JavaScript, but that most of this is conceptual. It doesn't really have to do with specific implementation. So it should carry over to whatever language you're using in your GraphQL backend. So in this talk, we're going to cover a couple different things. We're going to talk about just some Auth background, get some terms out of the way. Then we're going to talk about the what and why of JWTs. And then we're going to talk about authorization in GraphQL, and we're going to walk through some code and things like that. So let's get some Auth background first. The two biggest terms that you'll hear about with Auth are authentication and authorization. So let's define those before we move on. So authentication basically means, are you who you say you are? Sort of proving your identity. And then authorization, on the other hand, is, do you have permission to access resources? And so if we think about those terms in the context of GraphQL, we have our user, right? And then we have our GraphQL backend. And if you think about it, the GraphQL backend is really just a layer over our database. So GraphQL doesn't really necessarily care if you are who you say you are. They just need to know what permissions you have or what access you have to the data that you're trying to request, whether you can read it and write it and that kind of thing. So typically, the GraphQL server doesn't necessarily need to care about authentication. It mostly needs to care about authorization because it cares about who has access to what. So we've talked about access. Let's look at that in a couple of different scenarios. Here's sort of a really standard common scenario where you have the back end and the front end on the same server. So for example, maybe you've got like GraphQL and Next.js on the same server. So you've got a back end and a front end coming from the same server. So the user sends their credentials over to the front end, and then the front end sends it back to the back end, and the back end creates a cookie and a session, and then sends that back to the front end. So this is a really common scenario, and that's a totally legit way of doing it because your front and your back end are on the same server. So there's an easily traceable path of the request and the credentials. But a lot of bigger applications don't do this. A lot of bigger applications, maybe you've got maybe you've got a back-end server, and then you've got a bunch of different APIs in the cloud, and all of that is coming together in the front end. Or maybe you have an API gateway, and your API gateway is in front of a bunch of other APIs or services, like maybe a bunch of Lambda functions or something like that. And so then the issue of access becomes a little bit more complicated because we're not just trying to get resources that are on the same server. We're trying to get access to resources in a bunch of different places. And so what we're concerned about really is this thing called delegated access, where we're trying to get resources on outside servers, not just what's hosting our front end. So we go back and look at this scenario, and then we have our servers and our APIs. What we're trying to do is we need some sort of some sort of thing to be able to verify that the user is allowed to access those things. And cookies don't really work for this. Cookies are really meant for doing things on the same domain with the same server. So we need something else. We need something that can contain useful information, but that also can be signed and verified. We want to know if we're getting this from a completely different server, how do we trust it? How do we know that this person has access? So what is this, and how do we safely create it? Well, what we're talking about here is an artifact called a token. And the way we create it is with an authorization server. So an authorization server is a server that basically helps make access control decisions in your app or your API. And one of the ways it can help with that is by creating an access token. So an access token informs the API that the bearer has been authorized. So the user checks out, basically. So the authorization server sends over this token to the front end, and then the front end sends it over to the API or the server, the GraphQL server in our case, and we can verify that everything is good and send the user whatever they requested. And this also works in the scenario of having multiple servers and with an API gateway. So an access token, you've probably seen it before. If you've looked at some request headers, you might have seen this authorization header with a bearer, with the word bearer, and then a string of a bunch of letters and numbers after it. And that's the token. And so we mentioned that we want something that can contain useful information, but that also can be signed and verified. So there's a format that's really convenient for this called JSON Web Tokens, JWTs. This is a commonly used format for an access token. It's not a requirement. It's not mandatory to use a JWT, but it's a very useful format for it. So JWTs, they tend to look like this. And at first, this looks nonsensical, right? It's just a bunch of letters and numbers, and it's kind of unintelligible. But it turns out what's happening here is this is actually JSON, and JSON that's been run through an encoding and then spit out to look like a string, basically. So because of that, we can store a bunch of information in it. And a JSON Web Token consists of 3 parts. It's got a header, which is the algorithm and the token type. It's got a payload, which contains all of the data as well as the claims in the token. And there are some that are mandatory and some that aren't. And then it's also got a third part, which is a signature. And this is what we can use to verify that the token came from the authorization server and it's meant for this particular API that we're working with. So now we've discovered a format that can do both the things that we need. We can pack information into it using JSON, but we can also sign and verify it. So an example of this that you might have seen, this is something that Hasura does, where it puts additional claims, or actually they want you to put additional claims into your JWT. And so you can create this section that has what's called a namespace. That's what that hasura.io/JWT/claims. And you can add a bunch of custom claims, and then that becomes part of the JWT once it's encoded. And so this will work with our scenario where we have our authorization server. It sends the token to the front end, and then the front end sends it to our GraphQL API. And so we talked about how GraphQL is mostly a layer over your database and isn't necessarily concerned with authentication. And that usually means that your user management will most likely live outside of your GraphQL layer. And that kind of leads to the question, should you just build your own authorization server? And this is kind of a hotly debated topic. In my opinion, I would suggest not trying to write that yourself. You can do some of the basics yourself, but when you get into it, you start to realize there are quite a number of things that you need to take into account. Like proper password controls, and what about brute force attacks, and how do you make sure that there's correct error messages? It's a lot to keep up with. So I would suggest outsourcing that piece of your app. I know you're probably thinking like, oh, of course, like you work for Auth0, of course you're going to say that. But it doesn't have to be Auth0. There's actually a number of these options out there, but I highly recommend if you're doing anything more than just sort of a sample app, if you're doing a bigger enterprise project or anything that's going to have a lot of users, you're probably not going to want to do the authentication piece yourself. Okay, so we looked at these different scenarios with multiple servers and an API gateway. So now let's get a little bit more specific and talk about authorization in GraphQL. So before we get into this section, I want to have the caveat. I feel like anytime you give a talk on backend stuff and data, like there's a lot of nuance and complexity in application backends and how data is structured. So consider these sort of guiding or signposts or suggestions. Obviously, the specific implementation and the design decisions, the architecture decisions you make are going to vary greatly depending on the state of your data and the priority you give to different things. But these are good starting points for you. So when we're going to get the token in our request, the incoming request to the server, it's going to be attached as this authorization header, and we're going to need to pull out the bearer token. And so then what we need to do is the GraphQL server is going to need to verify the access token with a public key. So remember we said that the token was signed. What happens is it gets signed with a private key, something that only the authorization server knows. But the authorization server also has this public key that other places can verify it and say, oh, yep, this actually did come from this server. And then once we do that, we can parse the claims out of the token for the authorization. So that's what we need to accomplish in our GraphQL server. So how do we do that? Well, first, we're going to grab the token from the request and add it to the context. So what we can do is we're going to use Apollo in a lot of these examples, but you could really, it doesn't matter. You could pull this out of pretty much any GraphQL server. You can pull the token out of the request headers and then do something with it. So we've got our token, and now we need to verify that it's a properly formed and signed token that came from the right place, and then work with it from there. So we need to create this method called verify token that's going to receive the token and then give us back the payload of the token, the decoded payload of the token. So remember, it's going to be in this format where it's going to say bearer, and then it's going to have the token. So we need to split out the actual token. We don't want that bearer. We don't need that bearer word in there or the space. So we can split on the space and then get the token out of there. And then we need to verify the signature. So how do we do that? Well, there's a technology called the JSON Web Key Set that we're going to use. And there are libraries out there that can basically do this for you. Your authorization server will have an endpoint, a publicly available endpoint that will list out the public key that you can use to verify the token. So what we'll do is we'll grab that from wherever our authorization server tells us to. It's going to have this .wellknown/jwks.json at the end of it. And we pass that into a third-party SDK that can help us make that call. So basically what we're going to do is we're going to call that endpoint and then go get the public key and return it. And then once we have that, so we're going to create we're going to call a verify function on a JWT library out there and pass in the token along with the public key. And then we're going to need to provide a few other options that will be used to parse out the payload from the token, like the audience of the API and a couple other things. And what will happen then is we should get our payload return from that. And if we don't get our payload, then we'll just throw an error and say that it's invalid. So an invalid token can come from either something that's not properly formed, or maybe somebody's trying to hack a token and form something themselves and they don't have the public key right. And so we'll want to let people know that it's an invalid token. So now we have our verify token function. And by the way, I'll have a link at the end to all of the slides and a whole bunch of resources. And part of the resources, I have an example of Apollo server and client that has this verify token function in it, so you can actually go look at some code. It happens to use Auth0 for the authorization server, but it actually doesn't matter. You could use it with any other authorization server. So where do we want to use this? We could use this inside of our resolvers. Every single time somebody makes a call, we could verify the token in our resolvers. But if that feels weird to you, it does to me too, because that means we'd have to reuse this over and over again, and that doesn't seem like it makes much sense. So the best place to do it is really in the context of our server. So in our server, we can create this create context function. We're going to initialize a couple of variables for the token and the current user. And the reason we're going to initialize them with some null values and just return them no matter what is that sometimes you might have a public endpoint or something where you're not going to require a token. So rather than erroring out every single time somebody tries to hit the server without a token, it's a little bit better to take that into account. Now, if your API does only have private endpoints, then you don't need to worry about this. But often you want some sort of public endpoint, even just to say or a public resolver of some kind, just to even be able to do some testing. So then inside of our function here, we're going to try to get the token from the headers. And then if we have a token, we're going to call our verify token. We're going to await that, get the payload, and then we can do something like grab the user from our database somewhere. So when I showed the slide of the parts of the JWT and the different claims, one of the claims is called the subclaim, and that's basically the user ID that's being used. So you can grab that subclaim off of the token and pass that into your database and go grab your user. So this is just one example of doing that. And then if there's something wrong, we can throw an error and return a 500 or something. Otherwise, we'll just go ahead and return the database and our token and our current user. And so then what we can do is use that create context function when we create the instance of our server. So we'll have our context and then pass the request into that create context function. And that's what will allow us to have access to the payload of the token and the user throughout all of our resolvers. So for example, let's say we had a create event, let me back up a little bit, create event resolver here with our standard arguments of parent args context at info, and we check to see if we have a current user on the context after we've grabbed it from the database with our token, and if not, then we'll throw an error. If we do, then we can pull that current user off the context and go check their permissions, see if they have the permission to do that, to run this function in the resolver, and then go create the record in our database. We can make this a little bit more elegant using composing resolvers. So we could pull out our isAuthenticated function as a higher order function, and then check for the context, and then return the next part of the resolver. That's a totally valid way of doing it. We could also pull out the has permissions check, the check for the permissions. We could pull that as a function as well, and then wrap our resolver, wrap our create event in the isAuthenticated, and then check for the permissions and go and create the record in the database. And so here's an example of what that check permission higher order function would look like, and then we could just wrap isAuthenticated and check permissions around our database call. There are a few different libraries in the ecosystem that I just want to point out that will do some of this for you. One is called GraphQL Resolvers, where you can just easily make an isAuthenticated and then return either the current user or just skip to the next resolver, and that's pretty useful. And then you have this nice combine resolvers function where you can just piece together and compose the different resolvers that you want. So you could have one for isAuthenticated, and then one for check permissions, and then the final resolver, which is the creating the event in the database. Another approach to this is through GraphQL modules. GraphQL modules does this nice thing where you can do this resolvers composition. So when you come to the create event mutation, then compose together isAuthenticated and check permissions before you call the rest of the create event resolver. Another approach to this is middleware. So one is GraphQL middleware. You could make this a little bit more elegant by having some is-authenticated middleware and then passing those in as an array when you create your server. And in fact, there's actually another library that's built on top of this called GraphQL Shield that's exactly for this purpose of permissions. There's another approach, though, to doing this authorization, and that's through custom directives. So rather than trying to do this in your resolvers, you could check these permissions with a custom directive. So you've actually seen these before. For example, deprecated is actually in the GraphQL spec. And so you might see on a piece of data that you're trying to get, you might see, for example, here we've got this event location has replaced the location field, and you have this deprecated directive on there. So you can actually create your own directives and do whatever you want with them. And directives have a few nice things about them. They're part of the spec, so it's an official, supported thing to do this. What they're really good for is changing behavior at runtime. And because of this, they have a lot of different applications. For example, this is great for internationalization when you have to change strings on the fly based on location and things like that. And so we can do this with our authorization as well. So we can use custom directives to actually control access down to the field level if we want to. So let's look at the anatomy of a directive. First, you have to give it a name. So here we'll give it has permission. Then you give it an argument. So we're going to give it a permission that is a string. And then you need to tell it where to actually use this directive. Here we're going to do it on the field definition, but you could also do it on the object and a couple of other different places. And so then we can define, we've got our directive defined, but now we actually have to tell our GraphQL server what to do when it comes to that directive. So this is, again, this is Apollo and GraphQL tools as an example. But basically what we do is create a class that has this visitor class. And we are essentially just saying, hey, when we get to a field that has this directive on it, what we want to do is pull that permission out of it and then grab the field out of it and check to see if we have our user. If we don't, then we're going to throw an error and say that we got to be logged in. If we do, then we'll call that has permission, check for the permission that's been passed in as the argument to the directive, and either resolve it or throw an error. And so then when we create our schema, then we'll pass in the has permission with that has permission directive class into our schema directives object. And so what's nice here is now when we create a mutation, when we define a mutation, we say, okay, we've got this create event mutation, and it's going to return an event, and we're going to add this directive, this has permission directive, and we want to make sure that the user has the permissions.create permission. So it's a really nice, refined way of doing these things. There are a couple of downsides to using custom directives for authorization that you should be aware of. One thing is that it couples your logic to your schema. And so it's not necessarily a bad thing, but it's something you want to keep in mind because it makes it slightly more difficult to modify your schema if you've already got logic tightly coupled to it. So it's just something to pay attention to. Another thing you want to keep in mind with these custom directives is that they can be quite difficult because you might forget, it's at such a low level in your schema that you might miss some edge cases. And so you might have to do quite a lot of testing to make sure that you've defined it in the proper way and that you've taken into account different edge cases and things like that. So powerful tool, and as the cliche goes, with great power comes great responsibility. Since we don't have a ton of time for custom directives, there are a lot of resources out there. Ryan, who just talked, gave a nice talk at GraphQL. I think that was GraphQL Summit a couple years ago, 2018. He gave a great talk on that. Also, GraphQL Asia that just happened in February, there are actually several talks that talked about custom directives, and some of them talked about authorization specifically. The Apollo docs also have the Apollo server docs also have some information on enforcing permissions with custom directives. So hit you with like a ton of information. So let's just do a quick review here. We talked about how GraphQL is a layer over our database, and so it's mostly concerned with authorization and access to data more than it's concerned with the authentication piece. We gave the example of regular access of GraphQL and Next.js on the same server where you could use a cookie and everything kind of is hunky-dory, but it's not quite going to cut it when we have multiple servers or an API gateway. And for this, we're going to need delegated access. And so in order to do that, we have an authorization server that will create a token that gets sent to the front end, and then the front end can send that to our API and verify everything, and then check the permissions of the user. A great format for an access token is a JWT. A JWT can store information. It can also be signed and verified, so we know for sure that it came from the right place. We talked about how the best place to check for the token, to pull off the token and get the claims, is in our context function. We can do this in context, and then in our resolvers, we can do things like check to see if we have a user and if they have the right permissions. We also mentioned a few different libraries that make this a little bit more elegant. We have GraphQL Resolvers that has this nice combine resolvers function. We also have GraphQL modules that lets you do a nice resolvers composition where we can just tell it, hey, when you come to the create event mutation, run these other ones first, the is authenticated and check permissions. And also we talked about GraphQL middleware, where we can have an array of middleware that we can attach to a mutation. Lastly, we talked about custom directives. We talked about creating a has permission custom directive on the field definition that then we could attach to our mutations. So to close out, I wanted to mention, some of you have probably seen this podcast that Nader Dabit runs, GraphQL Patterns, and they have a couple of great episodes on Auth that I highly recommend checking out. And they have a couple of nice like parting words for us. One thing is that you want to remember that good schema design is the most important thing. As with any backend and data design, it's kind of garbage in, garbage out. And so if you design your schema to require only as much auth as needed, sort of that principle of least permissions needed, that will make your life a lot easier. Another thing you want to think through is whether auth is needed at the object level or the field level of the different pieces of your schema. Lastly, don't design mutations that can change arbitrary objects. Make sure that you're being specific in what mutations are being done and what users are allowed to do them. And one last thing is to experiment with sending null values instead of throwing errors. This is another one of those trade-offs. On the one hand, throwing a lot of errors is not a great user experience. You could send some null values instead. But the flip side of that is that null values don't really tell you a lot of information. They don't let the user know anything. So it's another sort of dial to turn up and down depending on what you want in your design. So like I mentioned, I have all of these slides. I have a bunch of sample code, a bunch of resources, all at samj.im/GraphQL Auth. And I just really appreciate you all, and hope you have an awesome rest of your day.